In this lecture, we're going to see how we can set up custom type conversions for our own class types. And this is going to be through a bunch of operators that we can overload. Okay, so this is going to allow us to do transformations from one type to another. And to bring this in context, suppose we have a number class that is going to just be wrapping around an integer type. So this is a class we're going to be using in our program. We have a bunch of constructors on it, nothing really complicated, but we want to be able to do transformations from this number type to other types. And suppose we want to do these two transformations. We want to be able to transform from number to double, and we want to be able to transform from number to our point class that we have been building so far in this chapter. One way we have to set up these kinds of transformations is a bunch of operators we can overload on our number class. And we can overload the double and point operators just like you see here. So you can say operator, specify the type you want to be able to transform to, and then do this as an operator. You're going to put your parameter list. If it's not going to be modifying your object, you can mark this member function as const. And inside, you're going to do the transformation you need to do, and you're going to define how this transformation is going to work. For our double type, this is really nothing complicated because we are wrapping around an integer. So we are just going to cast this integer to a double and return that from this function here. One thing you should notice is that these kinds of operators have no return type because the return type is really engraved in the name of the operator here. So we don't need to be redundant by specifying the return type. If you put the return type, you're going to get a compiler error. C++ prevents that. Another thing you should know is that these kinds of operators can only be done as member function. This is a rule that is enforced by the C++ standard. So if you try to do this as non-member functions, you're going to get a compiler error. If you go down, you're going to see that we have another operator, which is going to be transforming from number to point. And it is a const member function because it's not going to be modifying our object in any way. It is just going to be carrying out the transformation from number to a point. And what we're going to be doing here is set up a point and return it from this function. Because the return type should be a point, this is what the name of this operator here is saying. So this is going to transform from a number to a point. And we are just going to grab the wrapped integer and use that to set up our x coordinate and our y coordinate. And we're going to return this from this function here. And this is going to be used by whoever called this function. And this is going to work. So these custom type conversions are going to be implemented like this. You are going to have to define what they really mean in the body of your functions. In this case, for example, for a point, we defined that we could use this wrapped integer both as an x and y coordinate, and this is going to work if this is what you want in your application. So take this template here and you're going to be reusing it anytime you want to do a transformation from your class to another type, and the compiler is going to pick up these functions and use them to do transformations. For example, if you do a static cast from a number to a double, or if you do a static cast from a number to a point, the C++ compiler is going to be using these operators that you have overloaded in our number class here. Okay, so once you have your type conversions operators done, for example, you can use them here. Here we have a function which is going to take doubles n as parameters. We have another function which is going to take a point as a parameter. We can head over to the main function and set up a number and use that in our function here. For example, you see that in our sum, the second parameter is a number that we cast to a double. And this is going to call our custom type conversion operator from number to double, and this is going to work. If we see our usePoint function here, we're going to cast our number to a point, and this is also going to work because we have the operators that can do the transformation from number to point and number to double, and this is going to work really well. One thing you should know is that if you happen to have constructors that can also be used to do the same transformations, your compiler is going to be confused as to what it's going to use to do the transformation. For example, here, notice that we have a constructor which is taking a number parameter, and this constructor can really be used to do a transformation from a number to a point. What the compiler is going to do is to pass that number as a parameter here and get out a point object that is constructed through this constructor here. So if you happen to have this constructor n and you have a custom type conversion operator from number to point, your compiler is going to be confused, and in most cases you're going to get compiler errors. You should be aware of this. Now that you know this, we're going to head over to Visual Studio Code and play with this a little more. Okay, so here we are in our working folder. The current project is custom type conversions. We're going to be using the code we have from the last lecture as a starting point again, because we don't want to redo the point class. So we're going to copy this. We're going to go up and put this in our current project. And then we're going to open this in Visual Studio Code by dragging and dropping on top here. This is going to open our project, and we want to take out what we have in the main CPP file because we don't want this. We're going to set up the code when we have everything done in our classes, and we're going to be reusing our point class to do the transformations and see a transformation from the number class to the point class. The first thing we want to do here is to set up the number class because that's going to be the main point of contact in this lecture. So let's do this. We're going to put in a number header file, and we're going to put in a CPP file for this. Let's do number.cpp. I am going to grab a number class I have lying on my drive, and we're going to be using this as a starting point here. And it is nothing complicated. It's just going to be a number class wrapping around an integer that is our member variable here. And we're going to have a bunch of functions to do our work here. We have a constructor, which is not going to do anything. The default constructor here. We have another constructor, which is going to construct a number object from an integer. And it is just going to grab the parameter here and use that to set up our member variable here. Nothing complicated. On top of the other things, you see that we also have an output stream operator done. This is the same thing we have done before, but this is going to be printing the number here on the terminal. We also have a bunch of arithmetic operators implemented as freestanding functions. You see that we are making them friends here. We have the plus operator, the minus operator, we have the multiplication operator, we have the division operator. We also have the modulus operator. That's why I chose this class here, because it's going to give you a chance to practice all these operators here. In this case, we're not going to make them in line, just to show you that you can also do these things in the implementation CPP file here. So we're going to head over there, and we're going to include our header file because we're going to need that here. So we can go down here and put in our implementation. And we have the implementation for our constructor. We have the implementation for output stream operator. And we're going to do our operators here in the CPP file. You see, we have our operator plus, which is going to be adding up the wrapped integers. And it's going to use these to construct a new number object that it is going to return. We have the minus operator, which is going to do subtraction. And we have a multiplication operator, which is going to be multiplying our operands here. We have the division operator, which is going to divide. And we have a modulus operator, which is going to be doing modulus on the wrapped integer here. Nothing complicated. So if we build and run this program, it is going to work just fine. So let's head over to the main CPP file. We are also going to include a number, and we can create a number object. Let's do this. We're going to say number and say n1, and we're going to put in a 22, for example, and we can print this out. We can say stdc out n1, and this is going to work. Let's try and build this with GCC to make sure it is really working as we expect. The build is good. We can bring up a PowerShell window and clear and run Rooster. This is going to run our program, and we're going to see that the number is 22 in this object here. We can even add them up. For example, we can std out n1 plus number. Let's do number 33, and we can do something like this. I think it's going to work. And if we build and run, we're going to see it print 55 as our number that we print on line 9 here. The build is good. We can clear and run Rooster, and we're going to see 55 printed out. You can try out all these operators. They are going to work just fine. But what we want to do is to be able to transform from a number type to either double or our point class here. And we're going to be doing that through the custom type conversions that we're going to do in our number class. But before we do that, let's put together the code that is going to use that. Okay, so what we want to do is to set up a bunch of functions that are going to be working both on double and point parameters. And we're going to be using our number objects here as parameters to call these functions. So we can set up a second number. Let's do number and say n2 and put in a 10, for example. We can do this. And then we want to be able to call our functions using our number objects. So for example, we might want to say double result equals sum and say n1 and n2. Okay, so this is something we might want to do. And we might also want to say use point and pass in n1, for example. We want code like this to work because we want to be able to transform from number to either double, and that's going to make the sum function work. We want to be able to transform from number to point, and this is going to make the call we are doing on line 19 here work. At this point, if we try to do this, we're going to get compiler errors because the compiler doesn't really know to do the transformations we need here. So the compiler is going to say cannot convert number to double because that's what we are trying to do here. The compiler is going to say it can't transform from a number to a point, and these are the errors you're going to get here. And we're going to fix this. So to fix this, we're going to set up custom type conversions operators, both from number to double and from number to point. And the way to do this is really simple. Once you know how to do this, we're going to set up an operator. So we're going to say operator double, and it's not going to take anything in. We're going to make this a const member function because this is really not going to do any modification on our class here. And another thing I should remind you is that these custom type conversion operators can only be done as member functions. So if you try to do them as freestanding global functions, you are going to get weird compiler errors. So now that we have this, we're going to hop over in the body and return a double from this function here. Notice that we don't have a return type. This is a rule that is enforced by the C++ standard. If you put a return type here, you're going to get a compiler error. Let's do this. You're going to see that this is not going to bode well with our Visual Studio Code editor. You shouldn't really do this. This is not supported. The return type is going to be deduced from the name of the function here, and that's how this is going to work. So what we're going to do here is return, and we're going to static cast to double from what we have in our member variable here, and we're going to be casting our wrapped integer. So we're going to say mwrappedInt, and we're going to cast this to double, and then we're going to be returning from this function here, and this is going to work. This is going to transform from number to double reliably. If we go back in the main function, we should see that this is going to work. This is going to be doing implicit conversions. The compiler is going to pick that up and use that. And I think we can comment out our use point call here and try to build and see that the implicit conversions are going to kick in. You see that the build is good. Now the compiler knows how to transform from a number to a double, and this is going to build successfully. And this is really cool. If we try and print out this result, we can do that. Okay, so let's build and run this. We're going to see that we're going to get the sum printed out correctly. The build is good. We can clear and run Rooster. We're going to see that result is empty, and we didn't put this out. We're going to say result, and we're going to build again. The build is good. We can clear and run Rooster, and we're going to have 32 printed out because it is 22 that we are adding to a 10, and the result is going to be a 32 as we see here. So our custom type conversion operator from number to double is working as we expect. The next thing we're going to do is to do another conversion from number to point. So let's do this. This is going to be operator point because it's going to be transforming from number to point. And it's going to be a cast member function because it's not going to be modifying our class here. And we have a squiggly line here. I think the reason we have this is because this file doesn't know about the point class. So we can either go on top here and include this. I'm going to include the point class, and this should work now. But this is really bad because includes like this are going to cause for this guy to be recompiled every time we change the point class. You could use forward declarations if you had moved these implementations in the CPP file, but we're going to just keep this like this for simplicity reasons. So we're going to head over in our body and we're going to return a point that we're going to build on the spot here. The point is going to be using the wrapped integer. So we're going to define how we could transform from a number to a point. And we're going to be using this as both the X and Y coordinate. So we're going to do an explicit static cast to double from mWrappedInt for our X coordinate. And we're going to do the same for our Y coordinates. Let's go to the same location. We're going to do a static cast to double from mWrappedInt. And this should do what we want. We're going to return the point here. And once we have this in, it should be picked up by the compiler to do implicit conversions from number to point. So let's go back to the main CPP file and we're going to uncomment the line 20, which has our call to the usePoint function, which takes a point, but we are giving it a number. The compiler is going to notice that the type we are passing in is really different from what we expect from this function here, and it's going to insert an implicit conversion from number to point, and this is going to work. Let's build and run. You're going to see that the code is going to build just fine, and the build is good, and this is going to work as we expect. And if we run the program, we should see the stuff from the usePoint function printing the data here. Let's do Control-Z to remove the madness I just put here. We're going to run the program and we're going to see that the information is going to be printed out here. Our point has the data 2222 because we just used the N1 object to call our usePoint here. And we're going to build a point object from this number here, and this is going to work. One thing you should notice is that these are implicit conversions we are doing here. We are calling our function with number objects, but the compiler is going to insert implicit conversions. One thing you can do if you don't want these implicit conversions is to mark your custom type conversion operators as explicit. If we do this, we can mark these guys as explicit. And at the moment we do this, what we do in main here is going to become invalid because the compiler is going to see that it's not allowed to use our operators in implicit conversions. If we're trying to run our program, we're going to come back to square one where the compiler doesn't know how to do our transformations because it can't use our custom type conversion operators. The only choice we have if our custom type conversion operators are explicit is to do the static cast explicitly ourselves. So we could come in our calls here and say static cast and say double and cast N1. And we could also do a static cast to double from N2. This should work now. And if we comment out the usePoint case here and build again, I think this should work because we are doing explicit casts. And we need to cast to double. This should be an angle bracket. It shouldn't be a parenthesis. I think that's why we have the problem here. Let's try and build again. We are going to use GCC. Now the build is going to be good. If we run our program, we should see our result printed out. We're going to clear and run Rooster. We're going to have 32 printed out. We could also do an explicit cast from number to point, and that's going to call our custom type conversion operator from number to point. And we're going to do our cast here. Let's say static cast. We're going to be casting to point, and we're going to be casting from N1 here. this should do what we want. And if we build and run the program, let's use GCC to build. Now the build should be good. If we run the program, we should see the data that we expect printed out here. And this is really cool. Okay, so now I hope you know how you can do any custom type conversion from your class. All you have to do is set up an operator which has the type you want to be able to convert to from your class. And in the body, you're going to do whatever operations you need to do to get the return type that you expect from this function here. And this is going to work. One thing you should be careful about is that this is only one way we have to do custom type conversions in C++. Another way we have, for example, is to set up a constructor from the point class which takes a number type. And for example, if we happen to have a constructor that took a number type, let's go in and do this. We're going to set up a constructor of point, and it is going to take a const number by reference. Let's do this. And this should be our constructor that takes a number type. And we want to forward declare the number class. Let's do this. And we're going to do the implementation here in the CPP file because we don't want to have problems by cross-including number and point here. If you go back to the number class, you see that we are including point. If you come back to point, you see that we are including number. That could lead to serious problems. We're going to avoid those problems by forward declaring the number class here, and this is going to be much better. So what we're going to do is head over to the CPP file and implement our constructor here. So we're going to mark it as explicit because we don't want this to be used in implicit conversions. So let's do this. And we are going to head over to the implementation for our point class. Let's do point CPP here. And we're going to include now the number class. Let's do this. And we're going to put our implementation for the constructor in front of our length function here. I think this is going to work. And we're going to take out the gibberish we have in the body here. So this is our implementation for the constructor. You're going to see that it's going to delegate the construction to another constructor that we have. It's going to pass our data, and we're going to explicitly cast from int to double, and we're going to be using this as our x and y coordinate. I hope you can understand this. And then in the body, we're going to just print something out saying that we are calling this constructor here to construct our point object from a number object. And please take a moment and realize that the compiler can use this to do a conversion from number to point. And if we go back to our number class, we also have a custom type conversion operator, which can do the transformation from number to point. So the compiler is really going to be confused if we do something like what we do here by calling the usePoint function. It's going to see that it needs to do a conversion from number to point, and it's going to find two ways to do the same things. It can either use this constructor and construct a point object from a number, or it can use the custom type conversion we have here to transform from a number to a point. And if we try and build this program, let's take out what we have on top here because we don't want to split terminal. If we compile this program, we're going to try this out with GCC, and the build is going to be good. And if we build and run this program, we're going to see that the compiler is going to pick the constructor here. But some compilers are going to be confused as to which conversion mechanism they can use if you have all these things in place. And I think that you should really be in control of how this works. So my go-to method is to only have one way we can transform from a type to another. If I want, I am going to be using the constructor we have here to do the transformation, or I am just going to leave in the custom type conversion operator I have in here. Some compilers are going to be confused if we have these two n, and some are going to give you warnings, some are going to give you compiler errors. But in this case, the compiler is trusting our constructor and using that to do the transformation here. And I think you should really be in control of what is happening here. And one way I can do this is to disable one of these ways and let the compiler use what we have provided For example, I can leave in our custom type conversion operators, and this is going to work really well. Let's go to the CPP file and make sure that the constructor is commented out. We can go to the header and comment out the constructor here. Now that you know that we can have these two mechanisms to transform from number to point, we're going to build again, and let's go in our number class and put in a few std out statements to know that our custom type conversion operator is being used. We can leave this in here. And if we build and run this program, let's do this with GCC. We're going to build. The build should be good. As you see here, we can clear and run Rooster. And now you see that a custom conversion from number to point is being done by our custom type conversion operator here. And this is really cool. This is really all I had to share in this lecture, showing you how you can transform from your class to other types using your custom type conversion operators. I hope you find this interesting. We are going to stop here in this lecture. In the next one, we're going to see that if we need to do implicit conversion in our operators, implementing our binary operators as a freestanding function is going to come in really handy. So go ahead and finish up here and meet me there.